Basic Skills 2. This one should be pretty easy because we have the posters in the room that you can refer to that show you how to graph the 3 different forms of quadratics, right? The 5-step process for each of those. So that's what we'll be using on this basic skills here. So let's start at number 1. So number 1, we need to identify the vertex. And if we're looking at the form that's given, right, we have x squared plus 4x plus 12. We need to realize that this is in standard form. Standard form to find the vertex, we use the formula, or at least we start by using the formula, negative b divided by 2a. Here's a, here's b, and here's c. So let's start plugging in. So negative parentheses, that negative stays outside. We look at the value of b. B is 4, so we plug in 4 here. And be careful, and again, that doesn't apply to this problem, but if b is a negative number, you're going to have a negative in here as well, which would end up giving you a double negative. But for this, we don't have a double negative because b is positive. Divided by 2 times a, and a is that invisible coefficient of 1 here. Right. So once we simplify this, we have the x value of our vertex. Now remember, the vertex is a xy coordinate, and this will give us the x. That's what we're working on right now. So negative times 4 gives us negative 4. 2 times 1 gives us 2. Negative 4 divided by 2 gives us negative 2. So now we have the x value of our vertex. In order to get this, we have to take our negative 2 and plug it back into the original equation. So we have, here's our original equation, x squared plus 4x plus 12. And we're plugging in negative 2 into everywhere we see an x. So here's x, that's negative 2 squared plus 4 times negative 2 plus 12. We grab our calculators, because on this one we can use our calculators. So we have positive 4 minus 8 plus 12. Or you can put that all into the calculator yourself. So 4 minus 8 plus 12 gives us positive 8. So there's our answer here. So the vertex of that, negative 2, 8. Going on to number 2. Identify the y-intercept. For any of these forms, to find the y-intercept, we plug in 0 for x. So anywhere we see an x, we're going to plug in a 0. So that'll be 0 squared minus 14 times 0 plus 59. 0 squared gives us 0. Negative 14 times 0 gives us 0. So all we have left is 59. Right? Or shortcut, in standard form, it's always going to be that number there. Because if you plug in 0, these will always cancel out. Number 3, identify the vertex. So vertex, we got to figure out what form this is in first, and it is in vertex form. Vertex form gives us the vertex without doing any work. The 2 numbers that we look at, that one and that one. This is h, this is k. Our vertex is opposite of h, comma, k. So if you look at h here, it's negative 4. We want the opposite of that, which is positive 4. And then k, which is out here, that's 7. We don't take the opposite of that. That stays the same. It's 4, comma, 7. Right, so opposite of h, comma, k. Number 4, again, identify the y-intercept. You always plug in 0 for x. There's our x. We're going to plug in 0. So 0 minus 7 squared plus 2. Simplifying this out, or you can just throw it in your calculator. 0 times negative 7, 0 minus 7 is negative 7 squared plus 2. So be careful of this double negative because order of operation tells us we have to do the exponent first. So what we're really looking at first is this negative 7 squared, which is a positive 49, plus 2. Let me go ahead and move this up here. Negative times 49 gives us negative 49, plus 2. That finally gives us negative 47. So the y-intercept, we need to state it as a coordinate. So we plugged in 0, and we got negative 47. And I believe I didn't do that up here for number 2 either. So we plugged in 0 to find the y-intercept for number 2, and we got out 59. And that is our answer there. Right, the y-intercept is a coordinate. Number 5, identify the X-intercepts. So we got to figure out what form we're given, and we're given factored form here. And factored form easily gives us the X-intercepts. So what we're going to do is we're going to take x minus 5 and x plus 7. Rewrite it here, equal to 0, and then x plus 7 equal to 0. And we're going to solve these. We're going to solve for x. So we get that x equals 5, subtract 7, and we get x equals negative 7. So now our two x-intercepts, right, these are going to be written a little different than the y-intercepts, are 5, 0. That's one of our x-intercepts. And the other answer is negative 7, 0. Those are our two x-intercepts there. All right, number 6, identify the vertex. So we look at what form we're given, and we're given factored form again. So factored form, we know we got to take these and set them equal to 0, right? Because we're going to be using p plus q divided by 2. So to identify the vertex, we got to figure out what the x-intercepts are. It's going to be 5, 0, right? And I'll let you guys do the math on these. And negative 1, 0. So looking at our two x-intercepts, we're going to label this here P. We're going to label this Q. So to find the x value, we do P plus Q divided by 2. Right, remember that vertex is the x, y value. We use that to find the x. So we start plugging in. P is 5 plus Q is negative 1 divided by 2. 5 plus negative 1 gives us 4. 4 divided by 2 is 2. So far we know our vertex is 2, and now to find the y value, we got to plug in 2 into the original equation here. So that's 2 minus 5, 2 plus 1. I replaced the x's with 2. And we simplify this. 2 times negative 5 gives us a negative 3. Negative 3 times 3 gives us a negative 9. And there is our vertex. So number 7, easiest way to do this is with your calculator, but you want to go ahead and write it out before you do put it in your calculator so you have a visual of it. So when x equals 4, we're plugging in 4 for x. So 2 times 4 to the second power plus 32 times 4 plus 1 34. So what you can do is you can throw this all in a calculator and get the answer as long as you're inputting it incorrectly, or you can solve them out by terms, right? You can split this up like this and simplify them. So looking at this first term here, 4 squared would be 16. 16 times 2 would be 32. Plus 32 times 4 is 128. And then plus 134. And finally, you can simplify all these. So you have 134 plus 128 plus 32 gives you 294. And that's your answer there. Okay, we need to do the same thing. So same instructions for number 8. We're plugging in 4 into there. So we have negative, parentheses, 4 plus 9 squared plus 1. Okay, so PEMDAS does apply here, just like it did at number 7. So inside parentheses first, 4 plus 9 gives us a 13. After parentheses, we have exponents. So exponents, we just have this section here, right? That negative is not included, so 13 squared, which is 169. So we have negative times 169 plus 1. Finally, this negative multiplies to the 169. That's negative 169 plus 1, which is equal to negative 168. Oh, and I'm forgetting to write these as coordinates as well. So we plugged in 4, we got 294. That should be our answer. We plugged in 4 here, and we got negative 168. That should be our answer. Okay, it's easy to forget to write them in coordinates. I just did it. That was my 3rd time doing it. All right, number 9, finding the average rate of change. So average rate of change, we need our formula. That's y2 minus y1 divided by x2 minus x1. So let's start labeling these up. So here's my x1, here's x2, y1, y2. So x1, y1, x2, y2, and let's start plugging these numbers in. So y2, we start out with negative 1 minus y1 is 7 divided by, right, so we got these 2 in there. We've got a minus sign included, so now we start with x2. That's negative 4. So x2, we got to bring this negative over, this minus sign. And then x1 is 2. So we simplify this out. Negative 1 minus 7 gives us negative 8. Negative 4 minus 2 is a negative 6. Okay, and what we need to realize here is that we have a negative divided by a negative. That's going to give us positive. Right? We need to simplify this. And then 8 divided by 6, this can be reduced by 2 on top and bottom. 8 divided by 2 is 4. 6 divided by 2 is 3. And that is almost our answer. Oh, that should be a 3. And that is our answer. Now number 10, stating the increasing and decreasing intervals. So this is pretty easy, but it gets confusing if you don't practice it too much. So here is our axis of symmetry. That's the line that cuts our graph in half. It cuts the increasing and decreasing, separates the two. So now if we're looking at our graph, you always want to read this from left to right. if we start left, right, if we start here and we follow our graph, we're moving upwards, which means we're increasing on this end. Let me erase this here. So now after the axis of symmetry, if we notice, if we follow our graph, starting from the axis, right, left to right, our pencil is going down, our graph is decreasing. So here's our decreasing side. Okay, now we need to state the intervals. So we have increasing, and then we have our decreasing. So our increasing, and again, we always want to start with the x's, right? So we use the x's to determine where the interval is from. So increasing was all this here going on forever. So increasing starts at negative infinity and goes all the way to that very top point there. So let me erase some of this stuff. It goes to this point here where it's increasing, and that's where x equals -1, right? So if we look, we kind of covered it up with the axis of symmetry there, but x is equal to -1 there. So we had it from negative infinity to -1. Now if we look at our decreasing starts from that -1, right, where x is equal to -1, and goes on, right, this is never going to stop, this is going to go on forever, as low as you go, to positive infinity. Right? And positive infinity, because if you look at our numbers, it goes +1, +2, +3, all the way up to infinity. On the left-hand side, it goes from -1 to -2, -3, -4, all the way to infinity.